In Part 5 of the Unit 3 notes, we are going to be covering ions. Ions occur when an atom gains or loses one or more electrons. These electrons are transferred to another atom, which also becomes an ion. A positive ion is called a cation, and a negative ion is called an anion. Ions will have a positive or negative charge in the top corner of their symbol, and this is known as the ion symbol. So here we can see some Bohr models. Sodium has this one electron in the outermost shell of its Bohr model, which it is going to transfer away to chlorine, which has an empty space in its shell. When sodium loses this one electron, it now has 11 protons, 12 neutrons, and 10 electrons. Because it now has more positive charge than negative charge, it ends up with a +1 charge overall. Now for the chlorine, the protons are 17, the neutrons are 18, and the electrons are now also 18 because it picked up an extra one. Since it now has more negative charge than positive charge, it's going to have a -1 charge overall. For our first checkpoint, we are going to find the number of protons, neutrons, and electrons present in Al plus 3. Now, even though this is aluminum plus 3, protons are going to be 13 because the atomic number defines the element, and the number of protons is never going to change. So this plus 3 only affects the electrons and nothing else. For the neutrons, we are going to round our average atomic mass to 27, and we are going to subtract 13 from that. So we're going to have 14 neutrons. Now for the electron part. If you have trouble doing this in your head, you can consider using the equation protons minus electrons is equal to charge. Now let's consider what variables we have in this example. Our protons are going to be equal to 13 because we know the atomic number, we know it's aluminum. The electrons are unknown, so I'm going to leave that as E. We know that in the end it has to have a +3 charge. So 13 minus something is going to be a +3. The only number that would fit here would be 10. 13 minus 10 would give us the +3. So that is our protons, neutrons, and electrons for a positive ion. Now let's do one for a negative ion, S-2. The protons are going to be 16 because that's sulfur's atomic number. For the neutrons, the mass would round to 32. 32 minus 16 is going to be 16. For the electrons, we're going to use the same formula that we used over here. Protons minus electrons equals charge. I know my protons are 16. My electrons are unknown, but I know it has to be a -2 charge overall in the end. The only number that would fit here, which would give me a -2 charge, would be 18. 16 minus 18 would give me a -2. So that is the protons, neutrons, and electrons for a negative charge. If you want to check yourself, for positive ions, your electrons should always be going down. They should be less than the protons. For a negative charge, your electrons should always be higher than the protons. All right, for our next checkpoint question, we're going to be going in the opposite direction. So we're going to be writing out the ion symbol. We have 7 protons, 7 neutrons, and 10 electrons. The first thing we need to do is figure out what element this is. So what element would have 7 protons? And that would be nitrogen. So we're going to write out N. Now for the ion symbol, we also have to know the charge. And we said before that protons minus electrons is equal to charge. So in this instance, we have 7 protons minus 10 electrons, that's going to be a -3 charge, or 3 minus. We're going to put that charge in the top right-hand corner. So N minus 3 would be the ion symbol for this particular ion. For our next ion symbol, we have to find an element which has 11 protons. This is going to be sodium, Na. Now to determine the charge, we're going to do protons minus electrons equals charge again. So 11 minus 10 is going to be equal to a +1. So our ion symbol this time is Na plus 1. All right, for our final checkpoint question, we are going to be drawing Bohr models for these ions. So we're going to be putting together all the skills that we have accumulated thus far. The first thing we need to do is determine the number of protons, neutrons, electrons so that we can map that out. Protons are going to be 19 because that's the atomic number. Neutrons. We have a total mass of 39 minus 19 protons. The remainder would be 20. So that's my number of neutrons. The electrons. When we were talking about regular elements, this would have been 19. But this time it's an ion. And we know that protons minus electrons is equal to charge. So if I have 19 protons, and I don't know how many electrons there are, but I know it has to be a +1 in the end, that means that I must have 18 electrons. All right, now for the Bohr model portion of this. Protons are 19, neutrons are 20. I have 2 electrons in the first shell, 8 in the second. I've used up 10 electrons. I have 8 left for the total of 18. And all 8 of them can fit in my third shell, so I don't need to write out a fourth one. For oxygen, protons are going to be 8 because that's the atomic number. Neutrons. We have a total mass which would round up to 16. 16 minus 8 is going to give me 8 neutrons. Okay, for the electrons. If this was a regular neutral atom, it would have to be 8 to match up with the protons. But this is not neutral. This is an ion. So protons minus electrons equals charge. I have 8 protons. I don't know how many electrons there are, but I know it has to be a -2 charge in the end. So that means my electrons are going to have to be 10. So I have 10 electrons to fill in. Protons are 8, neutrons are 8, 2, and then 8 for my shells. So my total of 10 electrons. That concludes our part 5 for the Unit 3 notes. When we come back in part 6, we will be talking about isotopes.